Okay, subtopic number 4, which is on thermodynamic processes. So we have to be able to define the following thermodynamic processes. We have isothermal, isochoric, isobaric, and adiabatic. And lastly, you have to analyze the PV graph for all thermodynamic processes. So thermodynamic processes is a process where one or more parameters of a system, such as pressure, volume, and temperature, undergoes changes. Okay, so it can happen due to either an exchange of heat between the system and its surroundings, mechanical work being done on or by the system, and both A and C lah. There are four processes that we will be focusing on. We have isobaric process where the pressure remains constant, isochoric process where the volume remains constant, adiabatic process where there is no heat transfer, isothermal process where the temperature remains constant. Okay, so how can we represent a thermodynamic process? We can plot a PV graph. So this is a plot of pressure against volume graph. The process is shown as a line ataupun curve. So it can be a curve ataupun a line lah. The work done during the process can be determined by looking at the area under the line ataupun the curve. So area under this graph here is telling us about the work done. Okay. So if the work is positive, the change in volume is positive. Maksudnya it expands. That's why the work is positive. Kalau the work done is negative, it is because the volume is negative. So it is being compressed. So that's why the work is negative, because work is done on the system. Okay, next we have betul kasih jawab tadi, work done on the system. Betul lah. Okay. Alright, so this is the summarized version sudahlah of all four all four processes ni. Okay, so untuk isobaric process, remember the pressure is constant. So the first law of thermodynamics, formula dia kamu akan apply yang ini saja. So the sign convention semua ni tiga ni refer to subtopic number 3 tadi. So untuk PV graph or an expansion untuk isobaric process, the pressure is constant. So kita ada satu line macam ni je. So it can either expand ataupun compress. So untuk yang ini dia expand lah. So dari volume yang kecil dia pergi volume yang besar. So work done should be positive. Oh, ada satu. When to redo this, it should be negative. So work, yeah, bella. So this should be work less than 0. Okay, so it should be negative lah sebab dia kena compress. So dia punya final volume ni lagi kecil dari the initial volume. So ideal gas law yang kita boleh apply is Charles law. So we have Charles law. Charles law ni adalah when the volume per temperature is constant. Okay, so the initial volume should be equal to the initial volume and temperature is equal lah untuk final. Okay, next we have isochoric ataupun also known as isovolumetric. This one is when the volume is constant. So when volume is constant, there is no changes in volume. Work done should be equal to 0. Okay, so dia punya first law of thermodynamics jadi Q equal to delta U saja. So the heat transfer should be equal to the changes in the internal energy. Okay, so graph dia adalah macam ni lah sebab volume is constant. So initial pergi final. So this one is like this lah. Okay, work equal to 0. That's why tidak mention of any work here. The ideal gas law that we can apply here is the pressure law. Okay, so untuk yang ini pressure over temperature is constant. Okay. Next, we have isothermal, where the temperature is constant. So untuk isothermal process, when the temperature is constant, there is no change. There's no change in the internal energy, because internal energy depends on the temperature. So internal energy equal to 0. Dia punya first law tinggal Q equal to the work done lah. Okay? Alright. Untuk the PV graph pula, so it is a curve on the PV graph lah. So any curve that is closer to the origin here will have a much more lower temperature. So basically this curve ni represents the temperature, satu temperature, one value of temperature. Okay? Okay. Astaga, ni lagi tertinggal. Nantilah buat balik. Okay, so the pressure is directly proportional to one. Oh, okay, so it is indirectly proportional to the volume lah. Okay. Okay, is there any mistake lagi? Tidak. So the ideal gas law that we can apply for isothermal process is Boyle's law. So Boyle's law states that the product of pressure and volume is constant. So kita dapat satu equation yang macam ni lah. Okay. Next, lastly, we have adiabatic process where the heat is equal to 0. Okay, so there's no heat transfer. So when there's no heat transfer, work done will be equal to negative internal energy. Okay, so untuk expansion adiabatic process macam ni lah. Okay, dia punya temperature ada changes. So this is another temperature. I mean, this is one temperature, this is one temperature. Okay? Alright, so there's no ideal gas law punya that can be applied for adiabatic saja. But these three laws you need to remember. Sebab exam selalu akan tanya, dia bagi situation, then you have to apply these equations here lah. Okay? Alright, so that is on the processes. So the curve of isothermal and adiabatic on the PV graph, you could see that isothermal and adiabatic process looks really similar, but actually the adiabatic curve ni masih adalah lagi steeper. Okay, dia lagi steeper dari the isothermal curve. Okay, lepas tu adiabatic process ni dia involves two different temperature curves. Okay, so ni satu temperature kan, ni satu temperature. So untuk isothermal dia constant, dia satu je temperature line yang dia berada. Tapi untuk adiabatic dia dari satu temperature dia pergi satu temperature. Okay? Alright, so that is that. Now let's look at example 6 lah. An ideal gas is contained in a cylinder by a frictionless tight piston. So the cylinder So the cylinder is surrounded by insulation to prevent loss of heat. Initially, the volume of the gas is 2.9 times 10 negative 4 cubic meter. And then the pressure is 1.04 10 to the power 5 Pascal. And its temperature is 314 Kelvin. So we have to calculate the number of moles for the gas in the cylinder. Okay, so for this one, we have to apply the ideal gas equation dulu lah. Sebab kita tahu kita boleh guna PV and RT untuk solve for the number of moles. So the number of moles is gonna be, tapi ni I lah, semua I. Okay. So if you substitute all the values, you will get 1.16 times 10 negative 2 moles. Right? Question B pula, the gas is then compressed to a volume of 2.9 times 10 negative 5 cubic meter. And then its temperature rises to 790. So the second temperature is 790 Kelvin. So we have to determine the pressure of the gas after this compression. Okay, dia tanya lah berapa. So yang ini kita boleh guna, we can apply the equation of PV and RT jugalah. Okay, alang-alang guna P I V F lah final tadi, N R T final. The number of moles kita masih boleh guna tau, sebab dia tidak, the number of moles won't change. Okay, it will be constant. So PF is nRTF over VF. So the pressure yang kamu akan dapat is 2.63 times 10 to the power 6 Pascal. Okay? Okay, question C pula. The work done on the gas during the compression is 91 joule. Calculate the increase in the internal energy of the gas. So, if it is compressed, work done should be negative 91 joule. Lepas tu, dia cakap cari delta U. Okay, so cari internal energy. So, since the cylinder is fully covered, there's no, to prevent loss of heat, there is no loss of heat. This is an adiabatic process. So Q is equal to 0. So our Q delta U minus salah. Delta U equal to Q minus W ni akan tinggal delta U equal to negative W. So maksudnya kita punya delta U is just positive 91 joule. Alright? Okay. Question D pula, explain why there is a rise in temperature of the gas that takes place during the compression. Okay. So for this one, untuk PSPM, they should, I don't really think there will be an explanation punya questions lah. Usually kamu punya tu calculation je. Tapi this is just for your knowledge lah. So when the gas is compressed adiabatically, it does negative work. Yalah compression kan. So kita tahu kita punya first law of thermodynamics tinggal jadi delta U equal to negative W sebab Q is equal to 0. So the internal energy of the gas is increased in order for it to provide enough energy to do work lah. Since the internal energy is proportional to the absolute temperature, and a temperature temperature increases. Kejap. Let me just think. Okay, so the internal energy of the gas is increased. They increase supaya dia ada enough energy untuk provide the system enough energy to do work lah. Ya, lepas tu kan internal energy ni proportional to the absolute temperature. So the temperature increases, resulting a rise in temperature lah. Okay, tapi kiranya basically delta U ni kan proportional to the temperature. So if there is a rise in this, if the internal energy increase, temperature should also increase. Macam tu lah. Okay. Alright, so that is on example number 6 and subtopic number 4.